We have a Zenith Royal 500 long distance AM radio here, 8 transistor, unbreakable nylon. Well, almost unbreakable. And I have another model here that I repaired some time ago. That's the Zenith Royal 500. A little different model. And I believe this one works. Yeah, I'm in the Faraday cage in here, so I don't get any radio stations. And then here's an earlier model, the Royal Deluxe 500, and it's another beautiful. I believe it's 8 transistor as well, and I repaired this one. Yeah, got all kinds of interference in here and no AM stations. So anyway, we'll set those aside because this is the one that we need to repair for a friend of mine. The unbreakable piece is right here. So we'll take care of that later. He said that he put batteries in it and he had a little bit of sound. Not hearing anything. And what I noticed immediately was that he had the battery in wrong direction. So it may have taken out all the batteries. This battery was in wrong. So it was wrong. Flipped in the wrong direction. So what I'm going to do is pop all these out. And we'll put in new batteries. And we'll see if we get any audio. I don't spend a lot of money on batteries because I don't run these radios day in and day out. So there's no reason to invest a lot of money in pen light. All right, so we'll put that in that direction. Okay, and let's see if we get anything now. No, dead as a hammer. Yeah, it's just as dead as it can be. Double check our battery. Yeah. Actually, there is a little bit of static. Yeah, got a little bit of faint static. So let's turn it off and open it up. Don't know if those batteries are any good or not, but so there we have 1, 2, the output transistors right here, driver transistor right here. And then we have, you can look at the little diagram here. Yeah, output, driver, first IF, second IF, mixer and oscillator, and RF amp right here. So it's a little difficult to troubleshoot these on the top side like this, but let's see if we can get any kind of noise out of the amplifier. So we'll turn the volume all the way up And let's see if we can get any hum using the screwdriver test. Okay, nothing there. I can just barely hear a little bit of noise in the background here. Actually, you know what? They may be socketed. Let's see. Let's turn it off. Those transistors may be socketed. They are. Oh, wow. Look at that. And these are I wonder if it says right there. Yeah, 121-61. Whatever that is. We'll put these back in. Socketed transistors on a transistor radio. Okay. So we can wiggle those transistors, make sure they're in the sockets. Okay. So let's just take a look at it. We probably have capacitors on the other side of the board. I don't see any here. There's a detector diode right there. Speaker connections. Output transformer. So there's the driver. And we could check and see if the amplifier is working. By touching a lead on the driver. If I can get the okay, we got a pop. Okay. There we go. All right, another transformer here. I'm looking for screws to mount this to the frame. I see a screw down in there. I see a screw down in here. See it in there? Right there's a screw. And there's another one right there. And I see any more? Don't see any anywhere. ferrite coil seems to be intact. I don't see any broken wires on the ferrite. It looks like we have some fresh solder down in here. So let's take this loose, and that'll probably free up the top side. And it may just have be a nut on the back side, so it's not doing anything. No, that's, well, I can't tell. Yeah, I did loosen it up. So let's pop the batteries out. Yeah, there's a screw right there. Right there. Come on here. All right, so let's okay, our earphone is holding us up. Okay. All right, and our knobs. There we go. Let's see if we can get that one up without. Right, now there may be a screw underneath that. Yeah, underneath this. So let's, I'd hate to break that volume control if it was just a very gently. Okay, yeah, it's coming. There we go. Okay. It's just very stiff. Okay. This has got to come out. There we go. Okay. And there we are. Got some caps back here. Cap here. Okay. Cap here, here. The sockets for the transistors. All my wires are intact here, yeah. Yeah, all the antenna wires seem to be intact and soldered. Okay. So let's, this is just tape holding the capacitors in. So let's just remove that tape. We'll replace it with something. And let's just check these caps. Well, we can check them without. Yeah. Okay. Okay, that cap is open. That cap is almost open. That cap is almost open. So these three caps are shot. What about this one? Oh my. Can't believe it. All these electrolytics. Yeah, these three electrolytic, 1, 2, 3, 4 electrolytics are completely open. Yeah. Okay, well, let's just replace those and see what kind of performance we get after we do that. That's some serious tape there, isn't it? We've got red, 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 and red. So these three, the positives are down, and that one, the positive is that direction. So we've got a record of that. So let's do this. Let's do a, we're going to do a simple J-hook replacement. I'm going to cut that one there, and cut that one there. Let's just double check our, yeah, it's definitely shot. The needle is not even moving. And that is what, 16 microfarad. So we could put a 22, or we could put a 10. Let's see, 16, 17, 17, 18, 19, 20, 21, 28, 6. We can go 6 microfarad either direction. So let's put a 10 microfarad, 25 volt in there. Let's see that one. What does that say? .35 volt 10. Okay. And let's check it with our meter. Less than 2 ohms. Less than 2 ohms. You see that? Less than 2 ohms. That's good. And we'll remember our positive is this direction. So we'll Set it in just like that. Put a hook here. And slide it on to the end of that wire. Get just a little bit of that. There we go. Okay, there we go. A little bit of a hook on it. There we go. Solder that in place. Put it back under the green. There we go. And then put a hook here. Hook there. Okay. $50 microfarad, 10 volt. So closest equivalent would be 47 microfarad. Let's see if that's right. It's 33 microfarad. 47. 47 microfarad, 10 volt. What did we say? 10 volt. Okay, that's good. 47 microfarad, 10 volt. And the positive is up. Got to remember that. And it is 5 microfarad at 12 volts. So we'll do a 4.7 at 50, I guess. Let's try a different one of these. The ESR is going to be higher with a higher voltage cap. I believe that's the general rule. Yeah, see that's 10 ohms. That's not too great. Even though it's a brand new cap. Here's one that's 4.5 ohms, which is not the end of the world. But these are inconsistent. You can see the value, the quality of these caps. May leave something to be desired. We need to find a all right. So, oh, I need to put that back in the stash. All right, let's pop these batteries in here now that we replaced these 4 caps, and let's see if that helped us at all. Well, sure didn't hurt us, right? I got to make sure we get these put in right. Here. Oh yeah, oh yeah. Okay, you can see that we got some audio back, and so those caps really helped us out. But we obviously still have a problem. We're not getting any intelligence able to tune in any radio stations. To show you how this repair has gone, we've got the schematic here for the radio, and let's see, we're working with this little Zenith model Royal 500, and what I had in receiving it was just very, very faint hiss of audio, and so I immediately went to these capacitors here, these electrolytics. There's 1, 2, 3, and 4. There's one right under here, and let's see if we can find it. There it is, right there. Those 4 caps were all basically open, so I replaced those 4 electrolytics and immediately got full audio, but no intelligence, no music or voice, just a lot of hiss. And I had a squeal, a little bit of squeal when I would tune the tuning capacitor. I'd get a little bit of squeal, but no radio stations. So I started to do some probing around in the schematic, and let's get to the schematic here. And I started checking voltages, and I noticed I had 5.5 volts on the collector of this RF amp right here. But I had about 3 volts or 4 volts on the base and the emitter, which means the minus 3 volts and minus 3.5 volts or whatever on the emitter. So this transistor was not turning on at all. It was completely cut off. And so I thought, well, maybe that transistor shorted. So I checked that transistor, that PNP transistor, and it was fine. And in fact, I have another radio identical to this radio, and I just swapped that transistor out. Didn't make any difference. Still had 4.5 volts or whatever, 2.5 volts, I've forgotten, but it was way more than I should have. So I thought, well, let's trace this circuit down through this coil, come through this 1,000 ohm resistor to this number 3 right here. This number 3 line right here that goes up to this stage and up to the second stage, the mixer stage, is what we call the AGC, the automatic gain control line. And that line, and we're going to follow it here all the way down. There goes another leg up here to the oscillator and to the base of this first IF amp through a 2200 ohm resistor. So this number 3 checkpoint goes all the way over here to the volume control and the audio out of this is the audio output transformer. So there's the second IF, and then this is not the audio output transformer. It's the mixer IF stage transformer that ties the second IF to the output stage of the audio. So the audio is still a mix of the 455 kilohertz and the radio station. So we've got an amplitude modulated signal right here on this transformer, and when it comes through, magnetically coupled through this transformer, this diode strips off the positive side of the signal and sends the negative audio signal out to the volume control. And it also sends this negative bias of this audio signal is driving through this circuit all the way over, and is filtered out and becomes just a negative voltage, which sets the bias for this transistor. So if the signal is really hot right here, overly hot, it tells this AVC signal to shut down this transistor a little bit and reduce the gain on this transistor and this one, and yet even this one. So it shuts down the gain of the radio so that it doesn't overload the, let's get back on our, well, we lost our schematic. Where are we? So that leg has 2.5 volts on it, and it should only have really about a half a volt. And how do we know that? Because right there it says 0.5 volts. But I had 2 volts, or over 2 volts right there. So we traced it down, and we came over here, and I checked the voltages here out of the audio out, and anywhere on this test point 3 section here, up here, I had 2.5 volts. I thought, okay, that whole leg for some reason is loaded up. And where it's getting its power, I don't know. It's not getting it through the volume control because this capacitor is preventing any DC from coming up through here through the volume control. And this is audio stage down here, the driver and the output. So I've got the power supply right here. There's the batteries, 6 volts, comes up through, comes across here, it's filtered here a little bit, comes up to test point 4, and goes up to and is connected to the collectors. See, there's 5.5 volts, and we could trace it down. There's the connection there. We could come over here, go up, there's connection 4, come up here, 5.5 volts. I thought, all right, something is shorted to test point 3 that is forcing all of these emitters, this emitter, this base, this base, this base, all these bases, these transistors had 2.5 volts, so the whole thing was just shutting down. So I started to wonder, okay, where is this power coming from? It can't be coming from the AVC leg because there's no audio here. There's no audio here yet. There's just barely any voltage at all on this leg. So it can't be that this circuit is driving over 2.5 volts onto the test leg. So I started to check resistors to see if there was somewhere that it could have been shorted. And I looked here, okay, there's nothing there that has any power. Came over here, it came up here, there's nothing there. And I thought, wait a minute. What? This 20,000 microfarad or 20,000 picofarad cap is a ceramic disc cap that is tied directly to the collector, and it couples the audio that is tuned from the RF amp over into the mixer stage through that little cap right there. And I thought, well, those ceramic disc caps never go bad, but let's just assume that maybe it is bad. So I pulled one leg of this off, and sure enough, 150 ohms basically shorted. And so I just pulled one leg of this off, and all of a sudden all of my voltages dropped down to where they were, half a volt. So this cap was shorting this 5.5 volts into the base of this, and then 2.5 volts down the 3 leg up here, putting 2.5 volts here. So you can see how that could happen. And as also, since it was shorted, it was loading down everything. So with it disconnected, I still didn't have any audio. And I thought, well, of course I'm not going to have any music or anything because I don't have any path for the signal to flow. It comes out of the collector and goes over here and stops. So I dropped another, I think I put a 0.022 or a 0.03 picofarad cap in here, microfarad cap in here. And all of a sudden the radio came to life. I've got audio, I've got music stations, and although they're very poor, the alignment is way off on this radio. So now that we've got a signal path and we have audio working on the set, we will now follow the instructions for these alignment instructions right here. Well, if I can get to it. There we go. These alignment instructions. So we'll follow these alignment instructions and we'll realign the set. And it's loosely coupled to a signal generator operating at 455 kilohertz with a 400 hertz tone, and we just loosely couple those turns into the loop antenna of the radio. And then we'll just follow these instructions and see if we can get the alignment back to where it belongs. And so let's do that now. All right, we got our station set, everything set up. I've got a meter here that we'll adjust, and we'll listen to the audio, and we'll watch this bar move up and down instead of using a needle meter. The signal is laying right up here in a couple of loops. Just lay something on there, and it is tied in its loop and transmitting a signal into the antenna here. I've got the sweep generator. Let me jump up here. The sweep generator set at 455 kilohertz with a 400 or 300 whatever hertz tone. So let's turn the radio on, and we should hear a hum of the tone. Get over here and get this coupled. Okay, it's driving pretty hard. And we'll adjust this for the strongest signal, and we can watch the meter. Okay. Let's turn the volume down just a little bit. All right. Let's unhook it just a minute. Okay, so we've adjusted A1, A2, and A3. That was A1. So let's go to A2, which is A2, and A3. So A1, A2, and A3. A1, A2, and A3. 2. Okay. All right, now all three of those are good. So let's change it to 1600 kilohertz and radiate the signal in and adjust for maximum output. So we'll leave the tuning gain fully open and we'll set the frequency for 1620. So we'll come up here to the meter and we'll set the frequency to 1620. Okay. And we'll turn our modulation on. And we're going to adjust A4, which is A4, A3, A5, A6, A1. Where's A4? A3. Oh, it's on the A4 is right here. And it's the one on the inside. That's this one right here. Okay. All right. And what? Now we set the signal generator to 535, which is the low side, and we close the gain, close the tuning capacitor all the way. Okay, I had it backwards. The gain is now fully open. And so I need to go back and adjust these to 455. I had the gain fully closed. So let's go back to channel 1, which is our modulated frequency. We'll change this to 455 kilohertz. Okay, and then we're modulating. And we'll adjust these three again with the gain fully open like we were supposed to begin with. All right, so now let's change to closing the gang, and we'll switch to 535. So we'll switch the frequency to 535. Okay, and we're going to estimate 1260, which is somewhere between 10 and 14. We're going to say it's right there. And we're actually pretty close because we got a tone. So let's flip this over. And we're going to adjust A6, which is the antenna coil right here. I'm going to say right about there is it. Okay. Turn off the generator. And let's unhook our meter. We'll hook the speaker back up. Unhook the meter. And let's see if we have no antenna in here, really, but let's just see if we get any kind of signal. All right, after tinkering with this for a few minutes, I realized there were no signals in the house right here at the bench. So I wasn't able to tune in any stations. And so our next step is to put the radio back together and take it outside and away from all of this interference and see what kind of signals we have. All right, here we are on the front porch, and we're going to have to get out. Let's walk out here. All right, look at the difference that makes. How quiet that is. It's got pretty good selectivity. I've got my hands, I'm probably really creating a problem here with my hands on the back of the radio, but let's So that is definitely an alignment problem. So I'll go back in and realign the set, and I think we will be able to call this a successful repair. My friend will be very happy. But you can see the problem we've got with all the interference with the LED lights around the facility.